everyone, welcome to lectures by Aparna. In digital systems, memory devices are used to store information. These semiconductor memories are classified into two types. They are RAM or random access memory and ROM or read-only memory. In RAM, you can read or retrieve binary information that is stored in it, and also you can write the information into it. So there is both read and write operation for it. Whereas in ROM or read only memory, as the name says, you can only read information from it. This means some binary information will be already stored or embedded in it by the programmer by some hardware procedures. Now this data that is already there in the memory can be read or retrieved by us anytime, but we cannot write into it, and so this is read only memory or ROM. The block diagram of ROM is as shown. It is having K inputs and N outputs. The input coming to the ROM is address. It indicates the address from which you need the data. If suppose the address coming to the ROM is 00011. So there will be a data present in it, like, so here at the output, the data that is present in that address you gave. So in the address you gave, there will be a data present. So you get this data at the output of the ROM. So at the input it is address lines and at the output it is data lines. ROM is not having input data lines. There are no data lines at the input because it does not have write operation. So this 2 raised to k into n denotes the size of the ROM. If k is equal to 5 and n is equal to 8, so there are 5 inputs and 8 outputs. So 5 input address lines and 8 output data lines. So 2 raised to k by n is equal to 2 raised to k is 5 by 8, which is equal to 2 raised to 5 is 32. 32 by 8. So this is a 32 by 8 ROM. Means there are 32 memory locations in it. Like this, there are 32 memory locations and each memory location stores 8-bit data. So for each memory location, the 5 address bits will make the address. So here it will be 00000. In the next location it will be 00001. Like that there will be up to 11111. So this is a random data that I have taken. The internal logic of a 32 by 8 ROM is as shown. There are 5 input address lines that are denoted by I0, I1, I2, I3 and I4. 8 output data lines are denoted by A0, A1, A2, A3, A4, A5, A6 and A7. The input lines I0, I1, I2, I3, I4 are given to a decoder, and at the output of the decoder there will be binary numbers that are made using these 5 input lines. That is 00000000001, like that. So total there will be 32 distinct outputs from the decoder. So this will be 00000, this will be 00001, like that. So the decoder is a 5 by 32 decoder because it has 5 inputs and 32 outputs. So each output from the decoder represents a memory address. So each output from the decoder represents a memory address like this. So 00011 is a memory address. 00011 means decimal 3. So in the decoder output it will be here. Suppose the data present in it is this. This is just a random example that I have taken to explain. The programmer will already have put this data in this location. For logic 0, nothing should be marked, and for ones and into will be marked. At A0, for address 3, no connection because it is a 0. Now at A1, at address 3, you have to put an into. At A2 nothing, A3 nothing, A1 and into, A5 and into, A6 nothing, A7 into. Every 0 in the data specifies no connection at that point, and every 1 in the data specifies a connection given at that point. So the logic zeros will be programmed by the programmer by blowing the fuse links at these points. So when the address comes at the input, suppose the address coming is 00011, means line 3 of the decoder will be activated and all other lines will be deactivated. So when line 3 is activated, a signal equivalent to logic 1 will be given to this line. Since there are connections at A7, A5, A4 and A1, a logic 1 will propagate through the connections to the output of the OR gate. So you will get a logic 1 at these data lines A7, A5, A4 and A1. Since at A6, A3, A2 and A0, the programmer had blown the fuse links, and since there is no connection there, you will not get anything at the output. This will be taken as a logic 0, and hence you will get the data 1011, 00010 at the output data lines. So this is how data is read from the ROM when you give an address at its input. A ROM can be used in two ways. One, it can be used as a memory unit. Second one, it can be used to implement a combinational circuit. We have already seen how ROM acts as a memory unit in part 1 video. So today we will see how to implement a combinational circuit using ROM. So let's read the question. Design a combinational circuit that implements the following Boolean functions using ROM. F1 of ABC equal to sigma 01257. F2 of ABC equal to sigma 146. So here there are three inputs A, B, C and two outputs F1 and F2. The outputs are written as a sum of minterms. This form is known as sum of minterms. So first step is to write the truth table. In the truth table, there are two sections, input and the output. In input, there are three variables, A, B, C. And in the output, there are two variables, F1 and F2. Then there is a column which is the decimal equivalent of these binary numbers formed by A, B, C. So first we will write all the binary number combinations on the input side. So it will be 000, 001, 010, 011, 100, 101, 110 and 111. Now write the decimal equivalent of these binary numbers. It will be 0, 1, 2, 3, 4, 5, 6 and 7. Next, by looking at the minterms, we have to fill in the output column. For F1, F1 is 1 for 0. So in the place of 0 you have to put 1. In 1 also it is 1. In 2 it is 1. In 5 it is 1. In 7 it is 1. In all the rest of the columns you have to put 0. Next, in the place of F2 you have to put for 1, 1, 4, 1 and 6, 1. Rest of the columns you have to put 0. So these are the functions that you have to implement. By looking at the truth table, we will now draw the logic diagram. So a ROM consists of a decoder and then an OR array. The decoder should have 3 inputs, that is A, B and C. So 3 inputs, let n equal to 3. So at the output of the decoder there will be 2 raised to n, that is 2 raised to 3 outputs or 8 outputs for the decoder. So this is a 3 to 8 decoder. So we have to draw a 3 to 8 decoder. At the input of the decoder we gave ABC and from the output we got the min terms 0, 1, 2, 3, 4, 5, 6 and 7. Now we have to draw the OR array. Since we have to implement two functions F1 and F2, we will draw two OR gates. One for function F1 and the other for function F2. So we drew the OR array. Now we have to put an into mark in the place of ones by looking at the truth table. So we have to put for function F1, this output is F1 and this output is F2. So for F1, in the place of 0, you have to put an into because it is 1 there. Next, in the place of 1 you have to put an into. At 2 also into. Next at 5 an into, 7 an into. For F2, in the place of 1 you have to put an into, 4 an into and 6 into mark. This means that while programming the ROM, at all places where there is no into mark, here, in all these places, the fuse links have to be blown so that there is no connection coming from those points. So at all points marked into indicates a connection. So the programmer has to program it accordingly so that the functions F1 and F2 can be implemented. So in the ROM, only the programmer can write into it, but anyone can read these functions from it. So this is how Boolean functions are implemented using ROM. ROM is read-only memory. You give an input memory location or the address of a memory location at the input of a ROM, and you will get the data that is present in that particular address at the output. So everyone cannot write the data into the ROM. Only the programmer can write data into the ROM. That too through a programming kit or during the manufacturing process of the ROM. Hence the name says read-only memory because you can do only read operation with this. In which all purposes ROMs are used. When you press the on button of a computer, it is in the ROM that all instructions that are required to start this computer is stored. So ROM chips are used not only in computers but in many other electronic items like washing machine, microwave, oven, etc. It is in the ROM that a pre-programmed set of instructions will be there in these electronic items on how to function. In today's session, we will discuss various types of ROMs. The first type of ROM is masked ROM or MROM. These are the very basic type of ROMs available as memory chips or memory ICs or memory integrated circuits. If you want these memory chips for a particular purpose of yours, you send a list of data to be stored in the ROM IC to an IC manufacturer. It is a manufacturer who produces a mask, which is a photographic template of your required circuit. Then this mask is used for the mass production of your ROMs. So this type of method is used only for mass production because the manufacturing cost is high. So only if it is done in large numbers, it will be economical. For example, if you want to make a lookup table. That stores values of mathematical constants like logarithms, etc. You can store it in a ROM. You send your data to the IC manufacturer and they will put your data into the ROM through the method called mask programming. So mask programming will be used to make as many number of ICs you need, which is usually thousands or above in numbers. So this is called masked ROM or MROM. The second type of ROM is programmable ROMs or PROMs. For small quantities, it is more economical to use this type of ROM. A PROM allows the programmer instead of the manufacturer to store the data. For that, an instrument called PROM programmer. PROM programmer is used. Using this programming kit, the data will be burned into the IC by the programmer himself. So they are called programmable ROMs because the programmer himself can do it. He need not give it to the manufacturer for programming. But one thing to note is that this programming can be done only once. Once it is done, you cannot change it and it is permanent. So this is a programmable ROM. The third type of PROM is erasable PROM or EPROMs. As the name says, these are PROMs which are erasable. When the EPROM needs to be reprogrammed, you can place it under a special ultraviolet light for a given period of time and it will erase the programming that was already done and then you can reprogram it to a new set of values. EPROM is usually used in the developmental stage of a project. With EPROM, the designer can modify the contents until the stored data is perfect. When the design is finalized, the data can be burnt into PROMs or sent to an IC manufacturer who produce ROMs in large numbers. The fourth type of ROM is electrically erasable PROMs or EEPROMs or E-square PROMs. It is like EPROM only, but in EPROM, if you are using ultraviolet light for erasing, here electrical signal is used for erasing. The advantage of this is that you don't need to take this device out from the socket in your kit. You can keep it there in the socket itself and do the erasing. So these are the different types of ROMs or read-only memories. If this video has helped you, please do subscribe to my channel. Also don't forget to like and share this video. Thank you.